Hello, data enthusiasts. Welcome to the first episode of Learn with Vasco. I'm Sandro. I'm thrilled to be your host as we embark on this exciting journey into the world of data. So, what can we expect from this series Learn with Vasco? Well, buckle up for insightful decisions, hands-on tutorials, and expert tips that will boost your data knowledge. Today I will talk about an emerging orchestration tool known as Mage AI. Before we dive in, don't forget to subscribe if you're ready to embark on this data-filled adventure. Now, let's kick off the first episode. Before we begin the journey through Mage AI, we want to do a brief presentation of Vasco. After that, we will proceed with an overview of Mage and its general features. We will discuss things such as pipelines, blocks, scheduling, version control, integrations, and deployment. Last, we want to do a simple demo showcasing the tool. At Vasco, our mission is clear: simplify the complex and make the customer journey into something as effortless as crossing a bridge. We believe that by working together with integrity as our cornerstone, we can bridge the gap between complexity and simplicity, ensuring the journey is smooth and our client's business thrives. We believe in honesty, respect, and a wholehearted dedication to our client's success. Our approach is all about teamwork, analysis, and simplification. We start by delving deep into the intricacies of your business, carefully examining every aspect. But here, where it gets interesting, we don't do it in isolation. We firmly believe in collaboration and partnership. Our approach is all about collaborative partnerships, deep analysis, and a focus on achieving the client's goals. We want to deliver tangible results, enhancing efficiency and ensuring continuous progress. Vasco is a multinational consulting company, linking the might of process efficacy and efficiency in the Netherlands with the resourcefulness of its data competence center in Portugal. Let's have a look at Mage. What is Mage? Mage is an open source modern orchestration tool. It has built-in integrations for major cloud providers, AWS, Azure, GCP, and has Git integration. With Mage, we have the capacity to write SQL, R, Python, all in the same pipeline. We have these inside a very intuitive UI. We can develop, test, and deploy in a rather simple way. We can build custom integrations and turn into templates, and when it comes to triggering, we can do so in a very easy manner as well. Speaking of pipelines, these are developed by linking different snippets of code or blocks together. Each snippet contains an action for the data. Data validation and testing can be used also and ensure the quality and reliability of the data. We have a whole variety of connections that can be used to facilitate streaming, batch, and migration pipelines. We can monitor the runs in the logs page of the pipeline, and we can even trigger different pipelines. Blocks are the building foundation of the data pipeline, the bread and butter of Mage AI, as they contain our code. Actually, this is the main feature that differentiates this tool to other orchestration tools. We can edit block and add code directly on the interface. Each block maps to a file. A block can be added to a pipeline, and a block has the possibility of returning a data frame, which can be accessible in the next one. Additionally, we can include validation rules for testing in a block. We have various block types, such as the data loader for connections to data sources, the transformer specializing transformation, the data exporter allows the export data products to various platforms, Snowflake, Redshift, BigQuery, etc. Scratchpad, which are blocks to experiment and test, sensor blocks that check for a condition on intervals of approximately 10 seconds. If the condition is met, then the rest of the pipeline proceeds. Then we have special type of blocks, like the DBT, the extension, and the callbacks. Triggers. Triggers are a way to specify how pipelines should work. These are useful for automating and orchestrating based on different conditions and events. At the moment we have three categories, like the schedule for running pipelines periodically at a specific time. We have the API for running pipelines by making a post request on the Mage API endpoint for that trigger. Mage provides this API endpoint. And the event for running pipelines after a specific event occurs, like a file upload, file deletion, etc. At the time, we only have the connection possible for AWS S3 buckets. In the context of triggers, there is also a possibility to override global variables when useful. This can be accessed within the pipeline. Additionally, we have options to configure the timeout and the SLA. When it comes to deployment, one can install the Python library locally. Can also deploy a Docker image, and it is important to mention that Mage is cloud agnostic, meaning we can deploy that Docker image into any cloud service that allows it. For example, if we use GCP, Google Cloud Platform, we can deploy it on a VM instance or a Cloud Run service, depending on the use case. Additionally, it is required to add a firewall policy to the Google VM's endpoint and allow access to the port where the web service is being served. When it comes to version control and the whole CI/CD workflow, we found that the best way to do so in Google's environment is to follow the architecture in the slide. We can either Terraform or manually create and connect the services. So, what does this architecture consists of? We have the local development that's connected to a GitHub repository, a cloud source repository mirroring that previous repository. We have a cloud build trigger that is looking at pushes committed to a specific branch. In our case, we used dev, UAT, and prod. A container registry that connects GCP to the cloud source repository, and a Cloud Run service that contains the app. Why a Cloud Run service, you may ask? With this service we can version the apps, keep the old versions online until all users log out of the app, and we can backtrack the versions right on the interface very easily. When it comes to integrations, we have a whole variety of them in Mage AI. Of course, we have the major cloud providers, AWS, GCP, and Azure. We have native connections like the API, Redshift S3, the Azure Blob Storage, Google Cloud Storage, BigQuery, and Google Sheets. We have various DB types, including NoSQL. We have integrations with Snowflake, DuckDB, Trino, DBT. We can use Spark for the data processing and have access to different kernels such as PySpark and Python. Some cool features that are present on Mage AI that we want to mention, like an inbuilt terminal for all the purposes you want, packages installing, handling files, git commands, etc. Visual representation of the git branch that we are, the ability to generate charts from the output of the block, the ability to create a dashboard from the pipeline runs, nice 3D representation of the pipelines as you can see on the image, a secret manager, a way to create and or document blocks with AI, with the OpenAI API key, an in-depth integration with DBT using either single or multiple DBT models, and also use DBT docs, and lastly the DuckDB integration. Well, we found some improvement areas, as currently Mage AI is not in a fully fledged solution, being at the version 0.9.59. For example, we found that implementing the CI/CD workflow can be very tricky and deal with a lot of infrastructure. We also found some bugs that we dealt with. for example with DuckDB, with Git and dbt. Additionally, we think that the PySpark usability is quite not there yet, but we are hopeful it will be. Now let's jump to the demo.
Okay guys, so let's build our data pipeline. Our data pipeline will consist of 5 blocks. We have the initial block that is a sensor block for checking if we have Parquet files inside a specific folder inside the bucket. Next, we want to load that data into a data frame. You're going to use DuckDB here. I have some documentation ready, very simple thing to follow along. After which we have some business cases, some transformations that we're going to do. And lastly, we want to export that data into BigQuery, into a table, and provide a few arguments there. And the final block is to transfer the initial file that we ingested the data from to a different folder. So, okay guys, so we're going to build our sensor block right now. Our sensor block will be called GCS Parquet files. And we're going to use the Google Python API method. So let's import those. We need storage and the service account from google.cloud and google.auth2 respectively. And previously I've loaded the data into a JSON file, the credentials, and we are going to go ahead and load that information. So by opening that file, that's in my case it's on this directory. We can load that information with the JSON. Of course, we need to import the JSON library as well. And we're going to create the credentials object. So we need from the storage, actually from service account, but credentials, we need to apply the method of from service account info and have a JSON ready for this. Okay, now we are gonna create a few global variables. We want to do this because we want to have some information that will be accessible in all the pipelines, so all the blocks can access that. And we can create global variables for this reason. I already have 2 created, which later I'm going to import them. And right now I'm going to create another one, which will be the destination folder. I will explain right away what it will be. It will be the out folder, so to transfer the file when the pipeline is over, but we can use global environments just like the documentation says. So let's import them. We just use the quarks and provide the key of the global variable and retrieve the value. Right here, we're doing that thing for the quarks for the bucket and the watch folder. And next, we can go and create our storage client to have contact with the storage environment from this Python environment. So we need to provide the credentials, and next what we want to do is have a list of all the files that are in that specific directory called storage, and from then on we want to sort them and retrieve the oldest, so that will be the first to be ingested. The list of blobs, provide the bucket, provide the prefix for our watch folder. Of course, it's an F string, and providing the delimiter as well. Okay, so now let's loop all the files within that specific directory and retrieve their names and their date of last modification. We're gonna loop that blobs list and retrieve only the file name. So here, because we get the information with the directory, we're gonna split the name and retrieve the last string of that split. Just so we get the file that will be ingested, only the name. After which we will have the date of the modification with the blob.updated method. Okay, now we want to import a parquet, only a parquet, so we filter for the extension. But first let's create a list, and this list will comprise of all the information that we have on the blobs. And if we have a parquet extension, then we want to append some information onto the list previously created. The information will be a dictionary comprised of the name of the file /blob and the date that will be the blob updated variable here. So we want to check if there are files here, and if there are files within our blob list, then we want to sort them by order of blob updated. And we provide our variable with the list variable. We provide the key, which will be a lambda on the date. And because we only want the first or the oldest one in this case, let's slice fetch the first one all. Okay, now let's go ahead and see what is returned. So we have our dictionary. Okay, next we want to provide this information into all the pipeline. So the next block will ingest that specific file. So one way we can do this, again, it's with a global variable. We just need to import that statement, global variable, that library, and I have it ready here. So we need the set global variable, and let's we need to provide the name of the pipeline. We need to provide our variable key, and then the value. The key will be ingest file, and the value will be the first in name. Okay. Okay, after this, because we have a sensor block, we need, if the condition that we are achieving is met, we need to return a truth for the pipeline to continue on the process. So in this case, we will need to create the return statement. Okay, guys, let's build our second block. It will be a data loader. We want to ingest the data from that parquet file that we previously fetched the path or the full name. We can go ahead and call it something like load parquet GCS. And let's delete all this template code because will not need it here. We will use DuckDB here. We need to import that library, and we also need to fetch the full path of the file. So the bucket, the folder, and the actual name of the file. So we can copy that information we already had, and we can then have the ingest file variable be also there. Then we can go along to our DuckDB information and documentation. We have the page, read from S3 Parquet, and we need this library or this package and install it and load it, and setting three things here: the endpoint, the access key ID, and the secret access key, which are available when configuring the HMAC keys of our bucket. Lastly, we will need our SQL statement to actually read the file. So let's copy this into our code, and then we'll manage what we need and configure this into our specific case. So we need to envelop this in strings and perform the duckdb.sql function. So duckdb.sql and stringing everything. Now we need to, after we create the HMAC keys that we referred previously, just in the folder, we can create secrets. Already created them previously. And yeah, we have the DuckDB access and the DuckDB access secret. And we need to use that libraries, and the way to fetch the secrets is by this method or this function, get secret value. So we get the secret value to our created secrets, and then the information is passed along. Now we need to make this have string, of course, and we can fetch and create our query. Our query will be comprised of the full path, so we need to provide our global variables that we imported, the bucket, the watch folder, and the actual file name. And we want this information to be a pandas data frame. So we need to import the library, and we will then create a data frame from the results of that SQL statement, which is what we want to return. So applying the method df, we then return this. And the results. Okay, after the results, we want to clean the data. So that will be our next step. Our data pipeline, creating a block, clean that data. That block will fetch the data frame that was a result in the previous block, and then we can manipulate it the way we want. So we will create a custom block. We'll need to import a few statements here. We want pandas and numpy. And let's provide the data frame here. We actually need this to access previous block data. So a data frame has been provided, and I also want to return a data frame, just for clarity's sake. Let's delete all these, and now we want to gonna paste here our business case. So we want to remove both leading and trailing spaces and replace the remaining space with an underscore. We want to replace all Newark banks to Jersey City banks. So we want to replace the column city on those cases, and we also want to filter out banks from Kansas because let's say they are irrelevant. For the columns, we will create and strip columns. This eliminates leading and trailing spaces, and then we'll replace all the remaining spaces with an underscore. So using pandas string methods. Okay, this takes care of the columns. After which we want to replace the Newark banks, and we want to fetch the city column. And we want the city column to be equal, and we're going to use the numpy where, and we're going to replace all those values. So we provide this the city column where it's equal to New York. We want it to be equal to Jersey City, and when it's not, just keep having those same values. And then we will drop the rows that are from the Kansas state. We will filter out all those rows. So our DF will be our DF where the state is not equal to KS, which is the acronym for the state. And yeah, we had these main rows just as heads up. And now we will have few less rows with the column names accurately picked. Okay, let's build our exporter block. So we're gonna fetch the clean data and export it to a BigQuery table. Just gonna use the template here, very simple thing to do. Give it a name for our block, such as BigQuery export. And just make sure you have the credentials in the file and your config, your metadata, your config is correctly templated, and we're gonna fetch the information to create our BigQuery table. We need some things here. We want to have the file name to be the table name as well, minus a Parquet extension. And we're gonna need a few extra things. So I'm gonna copy what we'll need here, the variables, and our project ID. I have it here for our Google Cloud project. You need to provide yours. Mine is this one. Then I'm going to provide the data set. The data set will be this one, Mage Vasco demo, and the table name. Let's create the clean table name, which will remove the Parquet extension, the .parquet, and it will be just the file name without the extension. And that will be our table name as well. So yeah, just make sure that you have on your config.yaml file the path to the configuration, and this will work. Let's see if it works. Initializing, connection was a success, and the exporting as well. We can see here that we have a table, and Let's refresh, and we have a upload date. Hey guys, let's build our final block in our data pipeline. BigQuery's load was successful, so let's go and build that final part. Let's go along and create a data exporter. And our last block will be, its function will be to move the file that we ingested, the data that we ingested, and transfer that file into a destination folder. So from our watch folder that we previously saw to our destination folder. We need the same set of variables, so just gonna copy those here, and we can delete all this template code, because in the same way that it did in our sensor block, we'll use the same methods and functions. So we will use the Google Python API, and for that reason we need the same libraries as well. Also, to authenticate, we need to do in the same way that we did. So just gonna copy what we did before. We will need to create storage client as well, and we're gonna use a few methods to fetch both the bucket and the specific blob. So let's go ahead and create a storage client. Same thing as we did before. So we need to provide the credentials, and then we can go along with creating the bucket object. We need this to be able to move the files, being authenticated and creating these specific objects. So the bucket object will come from the storage client, and dot bucket providing the bucket name that sits under our variable bucket. After this, we create the blob object, which comes from that previously bucket object, and we provide also the full blob name. Here, because our blob/file sits inside a specific folder, we have to provide also that folder's name. And let's create actually the full path variable. We will use this again in the future, so let's create the replicable in an easier manner. After the blob object, let's create as well the destination full path. In the same way that we're going to use the initial path, we will need to use the final path. And the destination we created in the sensor block as an example, but we will need here to import it as well, so it's accessible inside our block. We're now creating the test folder variable, which will be the destination, and then we can go ahead and do our copy blob methods and our delete initial blob methods. So there's no real direct way to move the file. We need to copy it into another folder, and we need to delete the initial one. So we need to provide the blob object, the bucket object, and the destination full path for this. After which we can delete the previous blob and provide the original blob path. Okay, to finalize, let's return a print statement, just saying that it was successful. Simple print statement. Now we have our entire pipeline. Let's see if it works, and now it does work. Let's go ahead into the triggers and just say run at once. Okay, run now and see our logs information. The pipeline is alive and running. Executed the first block, the second block. So we have information. We loaded the data. We cleaned that data as well. It was exported to BigQuery as a table. We have that info there, and then the file was transferred as well. Okay, so let's refresh our bucket and see, okay, no files on our watch folder. And if we go to the destination folder, then we have our file that was backlistdemo.parquet. And let's see if we have that same file or that same table. This was the previous file that we saw, and this is now the new file. And we have all the information right there. Can do a little preview here. And yeah, that's it.